Okay, well, I can start with just a little bit of overview of what we're going to do. So we want to start doing more regular community calls just in general, and so this is a really good excuse to kick that off. We're going to shoot for monthly right now, just to keep it manageable. Um, and we thought that this first one would be really good to just do a focus on the textile threads. 30 minutes is a pretty short period of time to really go over all of it. Um, but we want to give kind of a really brief overview of threads as well as just what the team is working on generally, and then open it up for feedback and questions and give time to just talk about things that you want to bring to the table. For those of you that were able to register in advance of the call, I sent a link to the draft of the white paper that we've been working through. We've been doing this in LaTeX, so it looks nice, but it is still pretty early draft, we consider. We're really trying to just learn from the different people that want to use threads, what the key features of this next release need to be, and make sure that we don't develop down a dead end that isn't going to serve your needs. And so if you got that paper, I'd love it if you have a chance to look it over and get us any feedback or thoughts you may have about gotchas or just things that you need for your particular projects that we didn't cover, or just questions that you have about the way that we've written things up. Because it is a draft, just we're not really sharing it broadly yet, but we're hoping to, as soon as we kind of feel comfortable that the direction is fitting the needs of possible users. So, and then the rest of this call, yeah, that's my intro. We're just gonna do a quick kind of round robin on the team here about what we're working on, so that everybody can kind of have a sense of what Textile is up to right now. And then I'll give you, because I know that reading that paper in a day is probably way too much to ask, I'll give kind of the 1,000-foot view of Threads version 2, and we can share a little bit of kind of our implementation status there, which will come out in the team round robin too. But yeah, so I'll kick that off. I haven't been working on threads directly myself, although I've been working kind of tangentially. One thing that you'll see in the threads white paper that we've focused on really strongly is the layers of encryption for sharing data. And one feature of the layers of encryption is this follow capability of data. And so just really quickly, the way that the follow feature works is that there's a follow key for all data that's produced, and that gives the more or less the shape, the linkages of data in a data thread. And what that allows you to do is invite other services or other users that can do things like replicate that data without ever seeing what the actual content is. Well, the encryption of that layer also makes it so that people you don't invite can't actually see the structure of that data. And so that's been really interesting for us, and has us thinking a lot about networks of services that you can build around threads. And so I've been doing some early prototyping on that, and the prototyping has been focused on what you can do before you have threads access, because threads, this next version isn't out yet. So I've been just setting up some basic building blocks for creating those services. And the way that we're imagining those is, if you're familiar with textile cafes, cafes will essentially become service runners. And I have an example of that I will be publishing a blog post hopefully tomorrow about. And you'll see it doesn't touch threads yet, but you can kind of start imagining what would happen if it did touch threads. So that's me. Maybe I'll just, I'll call out the next person on the team to the right. So Ignacio, do you mind giving like a minute or two what you've been up to?
Yes, hi, I'm a new member of the textile team. I will start helping building on this new Threads 2.0 version. So hopefully we have some kind of good implementation soon enough.
So then next would be Sander, I see.
Hey everybody. Yeah, so we're just building out the major components of the new system, and we're doing it in a really modular way. So you can use the log implementation by itself, and you can stack them together to make threads. And you can then use the event store on top of that. So I'm currently working on just the thread orchestration, the network orchestration piece.
So the Carson next.
Yeah, hi. So my role in the new Threads deployment or rollout here is kind of twofold, which is working on the internals of the event store. So actually, like how we're persisting events into the local client and how we're materializing those views for client functions like, displaying photos in an app and that sort of thing, as well as the sort of developer experience end of things where we're doing some parallel development in JavaScript so that we'll have a JavaScript ready client as soon as possible when we finalize the Go version. So we're kind of doing those two in parallel so that the developer experience is pretty unified across platforms.
And Aaron.
Yeah. Hey, everyone. Yeah, so I've been focused recently on figuring out how exactly we want to do the mobile SDK implementation for this new version of Threads. What we did for the first version worked pretty well. We learned a lot about just kind of pain points for updating all those libraries whenever the core Go library would change. And we have some new ideas about how to streamline that process using gRPC. So been digging into that. Yeah, that's mostly
Cool.
what I've been up to. Yeah.
Cool. So let me jump into just the really quick overview of the Threads work that we've been up to. And Sandra, I'm going to tap you actually for some of the new stuff. But yeah, so if any of you have been following our work on the first version of Threads, we've been building the first version of Threads, almost since the beginning of Textile. We identified this need to do data orchestration across end users. And so Textile Photos uses the first version of Threads currently. We kept developing Threads as sort of an experiment in how to do this orchestration in a truly distributed or decentralized network for consumer applications. And I would say that we sort of developed the first version of Threads into a dead end. We kind of optimized it as much as we possibly could where it was. And so we stepped back and said, okay, so what did we learn from that? And what are the next things that we need to do to make the next version possible to go further and better? And some of the capabilities that we needed that we recognized in Threads version 1 as being weaknesses were things like, in Threads version 1, we have this concept of schemas, which is to define data structures on the way in. We found this pretty limiting for actually creating interoperable data. We found that in Threads version 1, all the peers in the network are required to basically push their updates to other peers that they're sharing with. And this left a lot of sort of losses and gaps in what people see. So if you use Textile Photos with big groups of people, you'll notice that your state in Textile Photos will often become sort of behind other people, or things will happen strange and it takes time to catch back up. There was a lot of, I don't know how to quite say this, but there's a lot of excessive data linkage in Threads, in the first version of Threads. And so that also led to some of these issues where multiple users sharing data would get to different states because the merging of multi-writer logs became complicated and relied both on the ability to do the merge and the completeness of the data that you had locally, and a couple of other issues. And so those compounding issues made it really difficult to actually build applications that scale. So in Threads, and then there's probably a handful of other pretty important ones. Identity was pretty locked in. And then this the encryption had sort of a very basic layer of encryption, which is good enough, but it doesn't allow you to build very interesting services or applications on top of your data. So we wanted to solve that. And then finally, the ability to invite or remove people from topics of data was kind of challenging, or not challenging, but it was too basic, and a lot of guarantees were sort of sidestepped about who had access to data in the early stages. So in Threads version 2, we've really been tackling each of those, and you'll see in the white paper that we're focused on single writer logs as sort of the basic core structure. So everybody maintains their own data set with their own linkages of data in that data set. And then threads is where those data sets are combined together. And there's a lot of different ways that you can combine the data together. And we do that intentionally because different applications are going to have different requirements for how they're combined. And those combinations will give you essentially lists of data updates. And those lists can be projected into views, which are very much like what you see in databases that you use now. So that data will be projected into a table, for example, or a key value store or a document. So that's one piece. The next piece is the access control, which is something that we've been focused on building at least one of the possible implementations of ACLs. We think that there's a handful of different ways that people want to manage access control. Smart contracts is a good example of possible access control backend. We also think that the events in a thread themselves can be used to build an access control list. And that itself is one of these projections that I mentioned before. And then finally, the last piece is the pull and push endpoints. So if I'm the maintainer of my single writer log, I can also designate other peers on the network to be places where people I'm sharing with can pull my updates. And so those could be cafes, those could be my desktop computer, those could be other members in my thread. And those we call, I don't know what we're actually calling them in the paper anymore, but essentially followers, but they're replicating my log, or they have the task of replicating my log. And that can help create these data sets that actually can scale and move a lot of data a lot faster. Sandra, do you want to jump in here with any maybe key things that you think I might have missed there? You're on mute though.
Thank you.
Yeah.
Just a point about followers, they don't necessarily have to replicate, and this kind of ties into some of the bot stuff that Andrew's been working on. They could do other things, like they could, trigger webhooks and trigger a chain of events. So that's why we're calling them followers and not just purely replicators, because some might be replicating, others might be doing other neat things for you. And then, yeah, I guess the other major piece is just from a 50,000 foot view, kind of the experience that we're trying to create, which is something like a normal developer is used to, like a Mongo or a Realm experience. And this is where the concepts like CQRS and event sourcing come into play, which you'll see in the paper. So this is sort of how you make just an object that you can interact with, and you can use getters and setters on this thing, and it generates events and changes state in a distributed manner. So we're really trying to create that experience that people are familiar with, like using a Mongo just to define the models you need, or a Realm just to define the schemas that you need in your application, and you're just sort of everything else sort of happens magically. What we learned with Threads version 1 a lot is just having to introduce new concepts. And I think some of that is acceptable, just in terms of, obviously we're in an early adopter kind of market here, so people don't expect to not have to learn a few new things, but just totally new concepts is not really practical for people to really like fall in love with the product. So we're trying to make it fun to use.
Yeah, cool. So that's kind of the 1,000 foot view that I promised. Maybe actually one more ask, Sander, could you do like a minute or two on where we are with implementation? And then we can jump into, well, actually, let me just say this before you do that is a big piece of our goal for this call was that we want to just get you the information on what we're tackling and give you some information for how you can get feedback. And like I said at the beginning, that paper is really draft, and this idea or these concepts that we're building, we're really looking for feedback. And so getting you to think through how you could be using it in your applications or how you want to be using it and letting us know that stuff would be awesome. I shared a very basic survey in the email that I sent last night. If you could fill that out at the very least, it would be awesome. But other than that, just jump on Slack and grab our ear. We'd love your feedback. But yeah, so now a couple minutes on implementation.
Sorry, 1 second. So on implementation, so we have a functional, so we're doing Go to start with, and we have a functional threads layer implementation. What I mean by threads is this a collection of single writer logs that are orchestrated across a across the IPFS network. And there's a bunch of details to work out there, but the next larger step up is the event store, which Carson is working on. Our first goal there is to just incorporate static ACLs that are materialized, and then we'll be working on this, essentially trying to figure out that the APIs, starting at the API level and figuring out sort of the CQRS pattern to derive shape from events. And that's the function of the event store. And the mobile is another piece. We're really going to try and not have such a separate code base for mobile. For now, we have a pretty entirely different API and build process for mobile. So this relates to the gRPC effort that Aaron mentioned earlier. We think that we could get away with just a single core API. And yeah.
Cool. All right, cool. So that's perfect because we have 10 minutes left and I wanted to just leave some time for any questions. I see that there's already some happening in the chat, which is awesome, but does anybody want to jump in and share a thought or question? Hey, Heracli, I see a mute coming off.
And then Michael Tumim,
Okay.
I saw your hand up too after.
Okay, let's go with that order. Yeah.
What was the order?
You first, and then yeah.
Yeah, I'm not sure if it's the right time to be asking a lot of questions. I kind of reviewed the paper and put some notes, and I still need to get it off my tablet to the GitHub or something more constructive. So there were a few things that I kind of was not quite sure I did understood. It felt like threads were doing two different things. One is this orchestration and projection, and the other one was, which appeared a little magical to me. So you could update things and to generate messages and kind of push it back to the thread. I guess I'm not quite clear on the details, or to me, it seemed like those ought to be maybe two different things. But maybe I just didn't quite get some detail.
Yeah, I think you're right in terms of the implementation. Like, so we can share some repos at the end of the call, but what we're calling this threads is really just the collection of single writer logs, which handles, it has a network API, and it deals with orchestrating events. And then there's the event store, which is more of the magical piece that you're talking about.
I see.
But we wanted to include both of those in the paper just because it's really about the experience as a developer more than anything. And we want to present that vision of how we think that this should work ideally.
Okay.
So
Yeah, maybe just terminology-wise, clearing it a little bit up might help there.
Yeah.
I'll provide some more constructive notes later.
Yeah, no,
Yeah,
that
that's great.
would be great.
I had more questions too, but I'm not sure if I should let others.
We can come back to you maybe after Michael.
Cool. I mean, and maybe this is related. I'm also, I think it's really awesome that you guys are looking at the developer experience and looking at like just a regular get and set API or something kind of like Mongo. I'm in that, like I guess I'm sensing that there's almost an impedance mismatch right now. Like you've got these threads in the low level and you've still got that API, it seems, and you're trying to build something on top of that. Is that what's happening? Yeah. So, now I've been doing some work also implementing CRDTs and other approaches. Just for a little bit of background, my main purpose is to get a common protocol for synchronizing state. So I've been looking at what is the API going to be for, and I think the networking, I'm looking at the networking protocol a lot, and then it's like, okay, what data do we really need, and what data is going to be common across different synchronization approaches, and it looks like so my first view of this is that this is promoting threads as the networking API, and then as like, this is how the data is going to transfer across the network in this append-only log. And then you're going to have on top of that, through views and projections, you're going to have some place that the developer is going to actually interact with it. In my experience, there is an impedance mismatch there that could cause problems down the road, because the data, especially if you're using like a CRDT or something, typically what happens is you have a patch or some kind of mutation event, some operation that depends on a number of previous states, a number of things coming in. And that means that the underlying data model is a DAG instead of an append-only log. And so I think that there are likely to be maybe some issues here. I guess a couple of things that I see is that one is, as a user now, it almost seems like I need to learn both of these APIs, both the threads at the bottom and then also, my Mongo-ish thing at the top. If I just want to transition to using the thing at the top, then I'm not going to care what's in the bottom anymore. And at that point, it seems like you probably want to forego the append-only log, where you're trying to enforce complete ordering, because all of these synchronizers are just going to want a partial ordering. So that was the overall impression I was getting when reading the paper. I wanted to at least share that.
I have one clarification there, because maybe I feel like you understand it, and so maybe I'm understanding your point wrong. So let me just say back to one thing about the paper, is that the single writer log is the only thing that enforces the ordering. Which is easy if it's a single writer, because they have basically an order. At the thread level, there is sort of a bring your own ordering. And so Carson's been working through some of those ideas right now, which that could be a distributed clock, it could be a wall clock, it could be a blockchain timestamp, it could be whatever your application needs. And so for most applications, they're not going to really care too deeply as long as something works.
Yeah, it could be no order also.
Yeah, so we'll have some basic thing, and perhaps it's no order.
Well, could I ask a question that maybe I'm confused about terminology? Is it the case that a thread is not completely ordered?
Correct. It does not have to be completely ordered.
Yeah.
Okay, see, so that confused me, because when I think of thread, I'm like, that's the metaphor for a single line of stuff.
Okay, cool.
Like a thread of computation, everything is completely ordered. And if you have multiple threads, now you deal with concurrency issues. So,
yes, threads sometimes is a complicated term, but yeah. So at the thread level, there's no requirement for total order or complete order unless the developer somehow wants to try and figure out how to enforce that. But there is that requirement at the log level, but that's pretty easy to handle because it's only one peer generating that, and so they can essentially, they know everything that goes into that log, so it's pretty easy to.
To map it to the CRDTs that you mentioned, you can think of every log is essentially actor operations, and thread is all the actors together. And the ordering will be done by CRDTs that you use, not by the thread.
Yeah. exactly.
Okay, so are all threads built upon these single writer logs? They are. Okay.
So a thread is a collection of single writer logs where the handling of the updates happens on the client. So the client would have a CRDT store potentially, if that's the data store that you want, which as it gets updates from these single writer logs will handle them, and they could handle them out of order, or they could enforce some sort of order or whatever. But the default would be that you don't need
to map it to, I think what you probably are aware of, hypermerge. So hypercore per actor maps to the log in the threads, and the hypermerge document would be your thread. Just you would use auto-merge library to do the like ordering for you.
Okay, cool. Yeah, if you don't mind, the two comments that I have on top of my head from this now is that one is the word thread is now confusing to me because I would think of that as being the underlying single thread. And then the other thing is that this does also require you to know all of the writers, since if each writer has to have a thread and you have to combine them all, and they all have to have kind of like known IDs, and that you might run into scaling issues if you want to have a large number of writers. If you just have the basic data model at the bottom just be a DAG itself, then you can still do all of the CRDT magic without having to know like, oh, this is an actor and this is an actor and this is an actor. And then each message within those actors' logs, instead of referencing other actors, they just message a message like, here's a patch, and this patch came from these multiple sources.
Well, I think, yeah, so one thing there is that technically the single writer log is a DAG. It just happens to be in a straight line. So you could apply like patches like that. So it still benefits from the Merkle DAG properties where I can get things out of order and I can get patches that might be out of order, and they just kind of plop into place wherever they actually end up being. Yeah, well, maybe that's a separate.
Forcing them all to be a sequence. Right?
Two more ideas there. One is that actually we've pushed that to the clock concept in the thread, where the clock could be, like we said before, it could be the wall clock, or you could have no clock and implement a CRDT. You could also actually bring a Merkle clock to the thread level and then get what you're saying. You see what I'm saying? So you could actually do that, but we don't force it to be that way. And also, one of the problems that arises from the model that you're proposing is then how do you have groups where you can actually ignore efficiently some members of the groups, because your updates may be referencing Sanders updates, which actually I'm trying to ignore proactively. So there's some weird issues that arise there that might have application-specific use cases. But since we're winding down on time, I don't mind sticking around for a couple more minutes, but I just wanted to make sure that any of the other people that haven't asked a question didn't want to chime in. Anybody there?
And then I would love to continue this conversation afterwards, Michael, if you're.
Yeah, this is really good.
Into
that. Okay, well, I don't hear from anybody else. So do we want to just keep going here for a minute or two?
Well.
Yeah, go ahead.
Well, one thing I'm learning from this conversation is there some like language either cleanup or like more clear definitions earlier on in the paper would probably be helpful. So thank you to both Irakli and Michael for that. I think that'll help clean things up a bit. And then why don't we talk through some of the sort of data model representation ideas here, if that's a goal.
I had one more thing that I want to mention, which I think is fairly important. So there's this somewhere in the paper, I don't know where exactly, it talks about the permissioned ACLs, which is, I think, somewhat reasonable to imagine how you do it on a table. If you think about projecting like CRDT document, that becomes a little trickier because like who gets to update which field is not necessarily clear how you would like incorporate it into the other projections that is more complex and simple table.
That's
I'm not sure if I'm describing it correctly, but this is one of the things that is actually,
Yeah.
I do not know if any CRDT research had been done in that, but I think it's interesting because like usually everyone can update everything, and how do you enforce those rules is somewhat interesting area to research.
Yeah.
And this seems to connect to what Andrew was bringing up also about ignoring some branches.
Yeah.
Yeah. So I mean, oh, you go ahead. You do it, Sander. Go.
No, I was gonna say that this is something that's a little hand wavy in terms of like the ordering of who can say that someone else can do something or not. And this is something Carson's been looking into, specific types of CRDTs for this. So
Yeah.
maybe,
I mean, to give you some context, our original idea was like, oh, we'll just have a like JSON CRDT document and we'll just update that document and that's great. But the potential problem there is that you lose some of the sort of like semantics of permissions because you want to say something like, look, I am the admin for this thread and I say that peer X can do these things. But if peer X was very clever, peer X might, and I was about to remove permissions, peer X might say, send some sort of update to that CRDT that is concurrent with mine that messes it up. So you have to think pretty clearly about that. Now, Threads is designed to be used in a collaborative environment. So like, that's not necessarily a threat model that we deal with, you know, explicitly, but some guarantees about consistency are important. So we started to switch to more specific CRDT structures for that ACL. And so, and we think that what we're talking about right now captures the semantics of permissions a bit better. But to Irakli's question, you know, we push permissioning and access control to agent-based or client-side control. So basically, any log could do whatever they want, and it's up to the client who's behaving to reference the ACL that they know about and behave accordingly. So the ACL CRDT is a sort of like feature of textile threads. So there's like threads, the sort of generic protocol, then there's textile threads, which may come with a sort of like privileged ACL CRDT, which the thread would reference every time it does an operation on its local log. And so that includes adding data. So if it, you know, the local client will say like, no, my CRDT says I'm not allowed to do that, so I won't because I behave. And it includes when fetching data. So it'll go, should I get this update? No, the CRDT says this person's not allowed to do that.
So this is actually one excellent thing that I want to, I think this is big source of confusion because you have textile threads, which is specific model for the data that is powered by threads. And then the threads that are like this threaded logs. And it's hard to context switch in the paper which one you're referring to. So I think it would be a good idea to kind of have two different names.
We may be able to push all that stuff to the end of the paper and then say like, here's the base stuff, here's the textile branded stuff, and kind of, I mean, branded isn't the right term, but.
I think it's also elaborating where the textile threads are would be helpful because I think it's like kind of order messages or ordered posts more or less the data model you're projecting there, but it's somewhat not clear. You have to kind of guess and from what Textile is doing right now. So it might be worth spending a little time in paper to try to sort that far.
Yeah, I mean, my bias is to be more opinionated in terms of like the implementation, you know, like just to have that stuff baked in for the base protocol, but it's a high wire walk, you know, because we want to have it be usable as generic as possible. So yeah, it's been a back and forth for sure. It's tricky to figure out where to draw the line.
Okay, I want to comment a little bit on the access control because I don't fully understand where the access control is happening, but I think it's happening at the, you said on the client, and is that in the thread and how they're pulling together updates from multiple single writers? So I don't know if this is an issue, but just something that comes to mind. Access control is like validation, and validation with CRDT stuff needs to happen, or it can happen at multiple levels. So you can think of it, if you think of a validation in terms, like for a blockchain, this is like my favorite example maybe. If you, so first you're gonna validate, you validate a transaction, which is updating like maybe some account and then debiting it from another account. And you say, okay, is that that transaction itself, is that okay? And you can validate that transaction is valid. But then if you have a new transaction come in that might also debit that account at the same time, it's possible for that new transaction to be valid, but the combination of the two not to be valid because you might have a double spend. And so you have this extra level of validation that requires knowing the CRTT's merge semantics to know that a state update is valid. And that is something that it might be difficult to handle if the validation is being handled at a lower level. I'm not sure exactly where it's being handled. I just wanted to throw this up as like an interesting case.
Yeah, it makes sense. I mean, so when we talk about threads themselves don't care about access control at all. They just, if you have the right keys, then you have the right keys and you can do whatever you want. When you interact with a document, so the way we're envisioning it in the paper is that the ACL is just a projection of events. It is a document itself. So when you operate on a related object, you're actually operating on that object, which then, you know, underneath interacts with the threads. So it's at the almost at the user level. On the receiving end, it's just agent based. So they just operate on, they just follow whatever rules they have currently at that moment. But this is definitely the crux of it that Carson was explaining earlier. You know,
Okay.
Obviously, how do you deal with like concurrent permission changes or someone just always bumping theirs ahead of everyone else? That kind of thing. It's really tricky.
Yeah, I mean, I think the like comment for that last example is basically like we would say that is a like that level of validation. So the validation that threads will do is just like, does this person have the keys? Yes. Okay, great. Then they can do that. And then that level of validation would happen at the client, or at the like view level before it actually derives a materialized view of the, so it'll have those log events, but it might say like, nah, it's not it. Like you can't do that operation. So, you know, the log's sitting there, but it's not going to do anything with it. So that would be pushed to the client. So.
Okay, so that means that as a programmer, I'm going to have two levels where I'm going to write my my typical validation logic. Like if I'm writing a web app, I'll have like my controller for a post, and I'll write some validation rules. But here I'm going to have some signature stuff, which happens in the thread part, and then in this CRDT thing, I'm going to have some additional validation logic.
Yeah, and so the signature level will get taken care of for you at the thread protocol level, but the other stuff you're responsible for doing that. And then
So
part of the, yeah, sorry, go ahead.
As far as I understand, ACL, like this data structure, will be handled for you as well. It will have predetermined update rules, so it will be updated. It's just in your application, before you accept the merge, or in deciding the order, you will look at the ACL and say, well, this doesn't seem right, so I'm not going to do it. And I'm going to reject or prioritize this one. Or if you don't do the CRDTs and do some other kind of projections, then you could look at the ACL per message and decide from there.
Okay.
Yeah.
Right. Yeah. So like the example in the white paper, I think we have is like a photo album of dogs, right? So that photo album itself has an ACL associated with it. So as a programmer, you could list or view that ACL, and you could try and change it, but the automatic updates that happen to your dogs album would be validated for you based on that ACL structure. That's the idea anyway.
What are the advantages to, my inclination would be to have all the validation in one place. What are the advantages to putting the access control at a lower level and building that in?
I think the biggest advantage is with the follower framework that we have, which is so like you can have an untrusted peer basically replicating and pinning thread content without any knowledge of the actual contents. So in that situation, you wouldn't want them to be able to validate the actual data itself. You only want them to track the fact that some update has happened. So you kind of have to have that access at a lower level there, so that they have permission to access the raw data, but not, or the encrypted data, but not the raw data.
You said you want a follower not to validate the data?
Not to validate the actual
The state. Right.
the actual semantic data.
I think it was a different question, actually. I don't think. Michael, if I may try, I think so. I think you're projecting that onto CRDTs, and I agree if it was only the case, then it would make sense to have it in one place. But I think the attempt with threads is not to only have that, you can also have cup architecture, in which case it becomes handy because you don't even have CRDTs there. Some applications don't need collaborative editing stuff. If you're just pushing messages, then you don't really want that. And I think for those use cases, it's handy to have access control being handled for you and not having to deal with that. Unless you can make an argument that everything should be CRDT, but that's a whole different.
But I think that's the strongest point here, is that in those cases, like we took a lot of inspiration from that, the Firebase of CRDTs. And so the idea here is that if you do want to build a custom CRDT on this framework, then you just ignore the ACL. You don't use the textile pre-canned ACL, and you can do it except for the validation, which is just, is this user even somebody you follow?
Yeah, that's just part of the protocol.
So if you consider like what Textile is doing, you post photos, you post messages, right? And you build up the sync, and everyone posts their own sync. I might be able to update my sync, but not Carson's message, because it wouldn't make sense. So ACLs are helpful. CRDTs might be a little overkill for that specific scenario, or maybe they're not. But that's again different.
Yeah, and it's actually pretty interesting because then you can you could potentially nest things here, and I think you were just kind of alluding to this a bit, which is like our team could actually have a thread which is documents, company documents, and a document might have its own CRDT with its own set of rules on top of it, but whether or not I can write a document at all it's handled at the thread level.
Right. So then in some cases, those are the the nested ACLs.
Even in these non-CRDT cases, it does seem to me like it might be equally useful to have access control within its own logic, using whatever it does. I think I see the idea of having an access control that everyone can reuse, and like a reusable access control system. But if it doesn't handle the specific case of whatever is on top or something up there, then you're going to have to write your own stuff there too. And then it just might be something that kind of gets in the way, and it's like, okay, I couldn't use a built-in thing here, we had to do this other thing. And you do have the two levels of abstraction to learn.
So I think it does. So if you do with the textile threads, which is not the thread, then you have all of the stuff built in. It just, access control is one component that you could reuse in building your own thing, as you could use these lower level threads. And you can bring your own clock. Just all the opinions with ACLs are kind of put together into, I think, textile threads. But then you also have those as components that you can reuse in building something else.
Right. Yeah, and it's also the single writer thing is helpful. And what pops out of that is the notion that, the only machine that is even capable of writing to a log is the owner, right? Because they have the private key for that log. So in a way, that is kind of access control, right? So if I can't physically write to your log ever, then I don't need to worry about, you don't need to worry about whether or not I have permission to do that or not. If that's helpful.
I think that provides the same amount of access control as like signing your messages. Like,
Yeah,
says,
exactly.
This message came from me.
Right. But it's harder in the world where we have this giant DAG that everyone can potentially write to. It might be you, but I might not. You might not have permission. You know.
What's harder there? Like
just being able to determine whether or not you have the ability, the permission to write to the single log. Versus if I can just see that you wrote to your log, then you have the permission to do that because it's just implied by the fact that you're the owner. I mean, I still need to know, like, can you actually even participate in the thread, but it's slightly helpful.
okay.
I don't know, we might be talking past each other here.
I think I understand what you're saying. Yeah, I do still feel like you've got these multiple, in the current spec, there's multiple levels and it's going to provide some stuff, but then not all the stuff. And then it might just end up adding multiple layers of complexity. And I think I guess my only suggestion is looking ahead a little bit about what it's going to be to have a CRDT or whatever is on top, and then saying, okay, like if we really do need to design this thing, do we want these lower levels? Because it just might end up being some extra complexity. And the systems I've been building, that's what it looks like.
Well, yeah, I'm just one more clarification. The user doesn't have to interact with the lower levels. That's the idea, you know, like they exist and they're modular.
With like signing messages.
But you wouldn't have to interact with that level as a user. You just, I mean, it just happens automatically, right? So this is like the notion with something like CQRS where you create some action which generates events, and those events will, you know, they'll be signed or whatever, right? And sent out to the network. But as a user, all you're doing is issuing a command, right? So your command could be add photo to album, or it could be grant access to Jane, comment on photo, these kind of things. So that would be the user API, and those commands generate events, which then alter state, which exists on other peers. So the idea anyway, is such that you wouldn't have to do anything more than just like issue these commands. And that's how people are familiar with building normal applications, right? Like I have some Mongo model for a customer, and I want to update their phone number. Like you just phone number update, save, you know, like that's the kind of APIs we ideally want to make. But yeah, your points are super well taken. It's really useful.
Could the other sort of like, I don't know if I want to say point of confusion, but like sort of sticking point here is that the two levels of access control are really, there's a level at the log level, which is the sort of like baked in piece. And then there's the level at the thread level. And the log level is kind of like there for various like just for encryption and data protection and like availability reasons. And then the sort of thread level is more like permissions to do things. And so
Gotcha.
the reasons for those different types of access control to exist are for different reasons. Like one is at the core data, like the core data transport layer, essentially the network layer.
Yeah.
And one is at the data model level.
Yeah, great. You know, I think that helped clear some things up in my head too.
Nice.
Awesome.
I think it's like, yeah, I mean, that low level is like a transport. Like that's equivalent of TLS.
Right.
It's
Exactly.
like this message came from
Yeah.
here.
Right.
Yeah.
Totally.
Cool.
Cool.
Okay.
Yeah,
Yeah.
and
And something that is access control, I think, also confused me. I'm like,
Nice.
okay, I'm gonna have to like configure my app here and put the users in there and stuff.
Ah, okay, interesting.
yeah. So the
Well,
ACL we're talking about actually kind of lives at the level of the final view. In fact, it is a final view. So you chop that off and you make whatever final view you want. You don't have to use that thing at all in your application. Yeah, cool.
Cool, man. It's really interesting. Thanks.
That's awesome.
Well,
I
this
was
has
wondering.
been great because I think we've just got a lot of things we can like kind of clear up in the paper. So
Yeah, that was really good feedback, guys. And thanks for sticking around for the extra 20. I was worried 5 minutes ago if we were not fully clicking there, but then that's great conclusion. So I think maybe we wrap it here. We'd love to jump on any follow-up calls with you guys. So if you have more thoughts, share them on Slack or email. But also happy to jump on another call in the near future. At the very least, we're going to have one in a month from now, and we can pick up some of this conversation. But we're moving pretty fast on the implementation stuff, just trying to get some basic pieces that people can touch and play around with some, hello world kind of things and see what we're talking about. But yeah,
we'll have a goal of our roadmaps a little bit, just like, soon TM. But we'll have a goal of having, I think we should have a public roadmap for these components.
Yeah.
It'd be good internally as well.
Yep. And actually, if anybody, like Michael or Irakli, if you guys have some examples of things that you're working on right now that like, you have in mind for something like that. Like, I'd love to hear about some of this work you're doing, Michael, around in this space. So
Cool.
Ping us on the Slack channel or email or whatever.
Yeah, great. I'll put my URL. This is the braid.news is my project.
Oh, cool. Oh, awesome. Yeah.
Oh, yeah,
we've been checking out that Braid stuff a bit.
Oh, great.
Yeah, that looks awesome.
Cool.
The site is amazing, by the way. I love how it clarifies how things get merged and everything.
Oh, great. Yeah, and my purpose is to like figure out, like, I'm kind of what are you guys doing and seeing what other guys are doing so we can get us all working on the same protocol. We're like meeting minds here.
I would suggest inviting Peter to the conversation. Peter, I don't know his last name, or I know his last name, I can't pronounce it. Yeah, PVH. So they're actually redoing auto merge in a very drastic way, and I think it might be worth thinking about it too.
Awesome. Yeah, I just
Did you say they're redoing auto merge?
Yeah, so they're changing to the binary format. That is, I'm not quite understood all of the details, but it is interesting, and it may not quite work out with the logs anymore, as I understand. So it might be worth getting his perspective on this.
Okay, cool. Awesome.
Michael, what about a crazy idea here? What if we did a follow-up in the near future and invited Peter and yourself and then one of us, and each just had like 10 minutes to present, our vision, and then, kind of open that up for us to share, like what you're saying, just get all on the same page and see, if there's overlap and if there are things that we're just co-developing, or if there's different use cases that we'll just all be fulfilling or gaps we're missing. Would you be into that?
That would be awesome, man. I just made contact with Peter for the first time last night in email, and we're like, yeah, let's meet up sometime. So
we could just make it like a virtual conference, and the three of us could present, and we could invite a lot of people to just watch for 30 minutes and then get some questions and stuff.
That'd be really cool. I can imagine like each person presents a little bit and then feedback on what they said, and then we move on to the next person.
Yeah.
Michael, I don't know if you're in the Bay Area, but
yeah, I'm in Berkeley.
Okay, so Peter is actually starting local first meetup. I think 12 was gonna be the first date, and I think they settled on Mozilla location in a sense after the homebrew meetup thing. So it might be worth following up, because we'll be there. If you both can make it, you might actually have in person. So,
great, Irakli, thank you.
Sure.
Okay, cool, guys. Maybe we wrap it up, and this was super valuable. So again, thank you so much.
I thank you guys. Yeah, it's just fun.
Yeah, thank you very much.
I apologize for getting a little funny there.
No, it was really valuable. it pointed
Yeah.
out some things we need to clarify at the very least. So cool. Thank you, everybody.
Thanks. Bye.